talking about ADHD, Attention Deficit Hyperactivity Disorder, and the treatments that are commonly used and the physiology behind both. So, ADHD has a few hallmark symptoms. First of all, would be impulsivity to decisions, which you make a reaction to something without thinking about it or without prior judgment. The inability to focus on a task, and hyperactivity, which essentially would be something of a disruptive matter, such as a kid inside of a classroom who makes disruptive comments toward the teacher. So, the physiology of ADHD. There are a few cortical regions of the brain responsible for ADHD. The first region would be the frontal cortex, or the frontal lobe, which is usually responsible for decision making. The other region would be the parietal lobe, which is essential for attention arousal. Yes, the neurotransmitters that are responsible as well inside of those cortical regions are the catecholamines, which the first one would be dopamine, which plays a role in the reaction to a novel stimulus and also processes rewards. And then the other one, the second catecholamine, is norepinephrine, and that's the response to arousal, which also goes hand in hand with the parietal lobe for the response to attentiveness. The common treatments, the first line of treatments for ADHD are a class of drugs called amphetamines. The most common amphetamines being Adderall, which is dextroamphetamine, and Vyvanse, which is lisdexamphetamine. There is also a non-amphetamine drug choice called methylphenidate, which is brand named Ritalin. However, today we'll be focusing primarily on amphetamines and their role that they play with ADHD. The pharmacokinetics of Adderall. Pharmacokinetics is the movement of a drug throughout the body, what the drug does to the body. Amphetamines are thought to increase the amount of norepinephrine and dopamine in those neuronal pathways that reach the parietal lobe and the frontal lobe, as mentioned before. They block the reuptake of norepinephrine and dopamine, and also enhance the amount of vesicles that are in the synaptic cleft to reach the postsynaptic neuron. There are a few marked clinical signs of amphetamine use, which the two most common being vasoconstriction and increased heart rate. Those two go hand in hand as well. The pharmacodynamics of Adderall. Pharmacodynamics is what the body does to the drug. Essentially, the duration of action from a normal Adderall would be 4 to 6 hours. That is the amount of time that it is actively working on the body. The half-life of Adderall is about 10 hours. So if you take 20 milligrams, 10 hours later, there will be 10 milligrams left in your system. 20 hours later, there will be 5 milligrams, so on and so forth. And how the body gets rid of it is there is an enzyme called CYP450, cytochrome P450, which is found in the central nervous system, specifically with large major highways of dopaminergic pathways, specifically in the substantia nigra, which plays a minor role in ADHD etiology as well. And it breaks down these the amphetamines and sends them to the liver for more processing to be broken down to be excreted through the urine. The side effects of amphetamines. Clinical side effects include social withdrawal, gastrointestinal upset, suppression of appetite, and then for the mental side, there is an increased mark of anxiety as well. There are also studies that suggest long-term use from 10 to 15 years of amphetamine usage could indicate neurotoxicity for dopaminergic pathways inside of the central nervous system from the brain as well. The future of ADHD treatments. there are these specific genes called GRM genes that encode for something called an mGluR, which would be a metabotropic glutamate receptor, which those receptors are responsible for enhancing the effects of catecholamines inside of the central nervous system. There is a compound that was founded in the 1980s called NFC1 that was used in the FDA trials for dementia. However, it was ceased because clinical trials didn't show promises for dementia. However, today NFC1 has resurfaced to enhance these um, metabotropic glutamate receptors inside of neurons to enhance the catecholamine flow between neurons. There are clinical FDA trials today going on for this drug. Thank you. That is the Physiology of ADHD and Amphetamines. I hope this was informative, and thank you and take care.